Hello everyone. All right, this is the third video on section 2.3. In this section, we're going to pick up where we left off in the last video. Where we're going to be working this exercise at the bottom of page 4. Before I do that, I want to make an additional comment about how to find these other two Pythagorean identities that we were talking about at the end of the previous video. Another way to get this tangent squared plus 1 equals secant squared identity is we could divide both sides of the equation by cosine squared theta. And then when you divide each term on the left-hand side, when you divide each term in the numerator, you have sine squared over cosine squared, which can be written as sine theta over cosine theta squared. And then cosine squared divided by cosine squared is 1. And then 1 over cosine squared can be written as 1 over cosine quantity squared. Well, then from up above here, you know sine over cosine is equal to tangent. So we have tangent squared, first term in this second Pythagorean identity. Then plus 1. And then on the right-hand side, 1 over cosine, right, we know is equal to secant theta from the second reciprocal identity. And so when I replace 1 over cosine with secant, I have secant squared theta on the right-hand side. So you can also get these identities by using that approach. And if you divide both sides of this equation by sine squared theta, you end up with this third identity. Okay? And again, these identities have to be memorized for the exam. They're not given to you on the exam. So let's use the identities in the rectangle to solve this problem here. We got to find the exact value of each of the 4 remaining trigonometric functions of theta if you're given this sine theta is equal to minus 3/5 and cosine theta is equal to plus 4/5. So from up above, we know immediately that the tangent of the angle theta is equal to sine theta over cosine theta. Well, sine theta is equal to minus 3/5. Cosine theta is equal to plus 4/5. And since these two fractions both have 5 as a denominator, when we divide the two fractions, we know the 5's cancel, and we're left with minus 3/4. So using the identity up above for tangent theta equal to sine theta over cosine theta, we know immediately that tangent theta is equal to minus 3/4. Cotangent theta can be found one of 2 ways, right? You can find it by writing this as cosine theta over sine theta, or you can take advantage of the reciprocal identity that cotangent theta is equal to 1 over tangent theta. Well, 1 over tangent theta in this case is 1 over minus 3/4. Dividing 1 by a fraction, the result is just the reciprocal of the fraction that you're dividing by. And the reciprocal minus 3/4 is minus 4/3. So the cotangent of theta is equal to minus 4/3. Cosecant theta from the rectangle up above can be found by cosecant theta is equal to the reciprocal sine theta. Right, it's 1 over sine theta. What's sine theta in this case? It's minus 3/5. And 1 divided by minus 3/5 is just the reciprocal of minus 3/5, which is minus 5/3. So using the reciprocal identity for cosecant theta, we're immediately able to find the exact value of cosecant theta. Secant theta is the reciprocal of cosine theta from the rectangle up above. Cosine theta is equal to 4/5. So secant theta is equal to 1 divided by 4/5, which is just equal to the reciprocal 4/5, which is 5/4. In trigonometry, you got to be able to work with fractions. Okay? You definitely have to be able to work with fractions. And so this is the answer. Right? All of this. Tangent theta, right? These are the 4 remaining trigonometric functions of theta. Tangent theta is equal to minus 3/4. Cotangent theta is equal to minus 4/3. Cosecant theta is equal to minus 5/3. And secant theta is equal to 5/4. Okay? So that's using the identities in the rectangle up above. Okay? If you flip over to page 5, we're going to use some more identities to evaluate some trigonometric expressions. In the first one, we got to find the sine of 40 degrees squared plus the cosine of 40 degrees squared. What's that equal to? Without using your calculator. Well, the first Pythagorean identity on the previous page says the sine of theta squared plus the cosine of theta squared is equal to 1. Right? That's the first Pythagorean identity in the rectangle on the previous page. Well, all we have to do is replace theta with 40 degrees in our identity, and we have the left hand side over here, right? Sine 40 degrees squared plus cosine 40 degrees squared. Well, if you put 40 degrees in for theta, what's that equal to? That's just equal to 1. All right, this identity holds for any number you put in for theta, for any angle you put in for theta. And so if we put in 40 degrees for theta, we have sine squared 40 degrees plus cosine squared 40 degrees is equal to the right-hand side, which is 1. So this is just equal to 1. Next we have, what's the tangent of 10 degrees times the cotangent of 10 degrees equal to? Well, tangent 10 degrees can be written as tangent 10 degrees divided by 1. And we know cotangent is the reciprocal of tangent, right? Cotangent theta from the previous page is equal to 1 over tangent theta. So if we replace theta with 10 degrees in this example, then we know that the cotangent of 10 degrees is equal to 1 over the tangent of 10 degrees. So I can replace in the second factor here, in this product, I can replace cotangent 10 degrees with 1 over tangent degrees. And now I'm multiplying two fractions, and when you multiply two fractions, you just multiply across, and we have tangent 10 degrees over tangent 10 degrees. Well, any non-zero number divided by itself is equal to what? 1. So this is just equal to 1. So tangent 10 degrees times cotangent 10 degrees turns out to be just equal to 1. And we found that by replacing cotangent 10 degrees with 1 over tangent 10 degrees. All right, lastly, we have tangent 40 degrees minus the sine of 40 degrees divided by cosine 40 degrees. What's that equal to? Well, from the previous page, we know that the tangent of theta for some angle theta is equal to sine theta over cosine theta. So if I replace theta with 40 degrees, I have the tangent of 40 degrees is equal to sine of 40 degrees over cosine 40 degrees. Right? I just replace theta with 40 degrees. So over here, right, I have a difference of 2 terms. I'm going to keep the first term, tangent 40 degrees. But the second term, sine 40 degrees over cosine 40 degrees, is the same as the tangent of 40 degrees, right? Tangent 40 degrees is equal to sine 40 degrees over cosine 40 degrees. So this fraction here is just equal to tangent 40 degrees. Tangent 40 degrees is a number. A number minus itself is equal to what? It's equal to 0. So this trigonometric expression right here just equals 0. And we're done, okay? We have evaluated each of these 3 trigonometric expressions using the fundamental identities on the previous page. Okay? All right, so let's take a look at the exercise on page 5, down below. And again, we're going to be using what we've learned to solve this problem. What we've learned on the previous pages to solve this problem. So given the information, we have to figure out what the exact value of the remaining 5 trigonometric functions of theta are. We're given that the sine of the angle theta is equal to 3/5 and that the angle theta lies in quadrant 2. So let's draw that picture. And when I draw the unit circle in the coordinate plane, it's easier for me to draw the circle first and then add the x and y axis through the center of the circle. Here's the x-axis, here's the y-axis, and then this is the unit circle. Right? It has a radius of 1 unit. All right, now the angle theta is in quadrant 2. So you know that here's the initial side of the angle, and then the terminal side is in quadrant 2. I don't know exactly where, but it's somewhere in quadrant 2. And the terminal side crosses the unit circle at that point. And you know that the point on the circle is an ordered pair. It has an x coordinate and a y coordinate. Well, sine theta, from the definition of the 6 trig functions of theta, is equal to the y coordinate divided by the radius of the circle r. Actually, I misspoke. This is not a unit circle, okay? This is a circle of radius r. And so we are using our modified definition for the 6 trigonometric functions that we covered in section 2.2, the end of section 2.2 notes. Okay. So this terminal side of our angle crosses a circle of radius r. Okay. So here's the radius of the circle r. And it passes through the point xy. X is the first coordinate, y is the second coordinate. Well, we know from the definition at the end of 2.2, when we're defining the 6 trigonometric functions of theta, that sine theta is not just equal to y, it's equal to y divided by the radius r. Well, in this case, sine theta is equal to 3/5. So when we set y over r equal to 3/5, we see the y coordinate is 3 and the radius of the circle is 5. So y is equal to 3 in this case, and the radius of the circle is 5 units. This is not the unit circle. I misspoke, okay? And I apologize for that. So this is our angle theta, right, drawn in standard position. And so the radius r here is 5 units. And the y coordinate here is equal to 3. So we know the y coordinate, we know the radius. What we don't know is the x coordinate for this point. And once we know the x coordinate for this point, we can find the 5 remaining trig functions of theta for this problem, okay? Based upon the information that we're given. Well, the equation of this circle of radius r, we know is x squared plus y squared is equal to r squared. X is the unknown. That's what we're trying to solve. Actually, I'm going to move this over here. X squared plus y squared is equal to r squared. Y is equal to 3 in this case. So we have 3 squared. And r is equal to 5, so we have 5 squared. Well, 3 squared is equal to 9. 5 squared is equal to 25. So we have x squared plus 9 is equal to 25. And then when I subtract 9 from both sides, I get x squared is equal to 16. Now this is sort of where the tricky part comes in. Square root undoes squaring, so we got to take the square root of both sides, right? Square root of x squared, square root of 16. But you have to ask yourself, in quadrant 2, is the x coordinate positive or negative? It's negative. So you got to put a minus sign in front of the square root on the right-hand side. So square root of x squared is x, and square root of minus 16 is minus 4. So x isn't equal to plus 4, it's equal to minus 4, because x coordinates are negative in quadrant 2. X is negative in quadrant 2. And now that we know x, y, and r, right, you have to use the modified definition of the 6 trigonometric functions of theta to finish the problem. Cosine theta is equal to x over r. X is minus 4, and r is 5. So cosine theta is equal to minus 4/5 in this case. Well, secant, is a reciprocal of cosine, and the reciprocal of minus 4/5 is minus 5/4. Tangent theta is still equal to y over x, and y is equal to 3, and x is equal to minus 4. So tangent theta is equal to minus 3/4. Well, cotangent is the reciprocal of tangent, and the reciprocal minus 3/4 is minus 4/3. And lastly, cosecant theta is the reciprocal of sine. We know sine theta is equal to 3/5. So cosecant theta is equal to 5/3. The reciprocal of 3/5 is 5/3. And we're done. We found the exact value of the remaining 5 trigonometric functions of theta, given sine theta is equal to 3/5 and theta is in quadrant 2. And so to do that, we had to use the modified definition of the 6 trigonometric functions that's found at the end of your packet and section 2.2 lecture notes. Okay? Alrighty. The next topic is even odd properties of trigonometric functions. I think I will save that for the next video. Okay?